Okay, I think 5.3 is by far your easiest section that you're going to have to do. Comparing linear and exponential functions, because you've already done it. Your basic thing that you're going to be trying to figure out is how do I know whether a function is linear or exponential? So let's write down a few things. Linear and exponential. If something is linear, it has a common difference. For example, it's going to go up or down by the same amount every single time. Meaning we're going to add or subtract the same number every time in a sequence of numbers. Let me give you an example. Y equals 2x plus 7 changes by 2 every single time. It adds or subtracts by the same amount. If I have a sequence of numbers like 1, 4, 7, 10, if you look at those numbers, they have a common difference. They add the same amount every single time. It's linear. When it's exponential, it has a common ratio. Different word. It means instead of adding and subtracting by the same amount, you're either multiplying or you're dividing by the same amount. For example, here's an equation that is exponential. You're going to learn that numbers like this get bigger and this one's going to triple. So the numbers in the sequence would look like this: 1/3, 1, 3, 9, 27, ... I don't know why my brain was just freaking out right there. I just lost my train of thought there. So you're going to have to look at things that are equations, and you're going to have to look at patterns of numbers, and you're going to have to determine whether they're linear or exponential. I think this is going to be one of your easiest questions. So when I look at your worksheet 5.3, you're going to look at tables, and you're going to have to check out and see, is there a common difference or is there a common ratio? Am I multiplying by something that's the same, or more adding and subtracting by the same amount every single time? And primarily you're going to check out the y values when you're looking at those things. Your x value should be consecutive. Doesn't have to be, but it's nice when it is. Okay? You're also going to have to look at some word problems and make a determination whether they're linear or exponential. So when I see this, you're going to have to decide in the situation for Sarah's fees, as if they decrease by $5 each time she visits that chiropractor. You're going to have to determine does that mean that she is going to divide by 5 every single time, or is she going to subtract 5 every single time? One's exponential and one's linear. I'll let you think about that as you do it, because that's an example. You're going to have other examples there as well. You're also going to have to evaluate and compare. I'll give you an example like number 7. What's bigger? Y equals 2x plus 1, or y equals 2 to the x plus 1, but they have to be specific. They have to say for what value, because we don't know where we're comparing. This is where we're going to compare. Y equals 2x plus 1, or y equals 2 to the x plus 1 for the value of x equals 3. So, which one's bigger? That's what we want to check out. I want to know, is it this, or is it this? Let's find out. Let's plug in 3 there. Y equals 2 times 3 plus 1. 2 times 3 is 6 plus 1. Y is 7. Or is it y equals 2 to the third plus 1? And 2 to the third means you have 3 factors of 2 multiplying each other. 2 times 2 times 2 plus 1. 2 times 2 is 4. Times 2 is 8. Plus 1 is 9. So when I'm comparing, the exponential equation is bigger than the linear equation for the value of x equals 3. It's not always the case, but it is the case for this particular problem. You'll have several problems like that. But what I really wanted to get you, the part that I think is going to be the hardest, is like number 14 and 15. I want to talk about that one real quick. Okay, I'm going to put 14 here and 15 here. Here's the equation. Y equals 0.5x plus 2. And the question on number 14 says, what is the average rate of change for the function y equals 0.5x plus 2 over the intervals from 0 to 1, and from 1 to 2, and from 2 to 3. Describe what you observe. What it's asking you to find is, what's the average rate of change here? What's the average rate of change here? And what's the average rate of change there? So I need to remind you of how to find the average rate of change. We've done it before, but maybe you weren't quite get it last time that we talked about it. If I want to find the average rate of change, I got to use a formula that looks like this. y2 minus y1 over x2 minus x1. That's how we find an average rate of change. That's synonymous with the slope. We're going to try to find what the slope is, or the average rate of change between these 2 points. And let's try it. Let's look at this and see what happens. If I'm trying to find the average rate of change between, let me remind you what our first interval is. It says from x is between 0 and 1. Then that means I can plug in 0 and 1 and figure out what those two values are. 0 and 1. 0 and 1. I'm going to put in 1 is bigger, so I'm going to use 1 and 0. When x is 1, I have to figure out what the y value is. When x is 0, I have to figure out what the y value is. So I still have to go and plug in this 1 here, 0.5 times 1 plus 2, and figure out what that is. 2 plus 0.5 is 2.5. I also have to plug in the 0 in to figure out what the y value is. 0 plus 2 is 2. And then I have to take the difference of these two things. I have to take 2.5 minus 2 over 1 minus 0. So there's a lot of steps to finding the first interval. 2.5 minus 2 is 0.5 over 1, which means that the average rate of change, 0.5 divided by 1, is 0.5. I'm going to find the average rate of change between 0 and 1. I'm going to find the average rate of change between 1 and 2, and find the average rate of change between 2 and 3. And then I have to describe what I observed, because this is only the answer to my first interval. So you're going to do the same thing. You're going to do this except for the next interval, 1 to 2. I'm going to cross off the number 15 right here because I need more room. So I'm going to do 1 to 2. So let's see. I'm going to do 2 minus 1, thinking of this formula. And I have to plug 2 in there into the 0.5. I know what 0.5 means is half of 2. So let me write that down over here. 0.5 times 2 plus 2. Half of 2 is 1 plus 2 is 3. 0.5 times 1, which I've already done. Half of 1 is 0.5. 2 plus 0.5 is 2.5. So I know that's a little hard to read. 2.5. There we go. 3 minus 2.5 is 0.5 over 1. And I get another average rate of change of 0.5. What this worksheet is really trying to get you to understand is that the average rate of change is going to be one thing for this type of equation. I hope you know which it is. It's linear. Versus, what's the average rate of change for something like this? This is exponential. So what I did earlier by plugging in the 1 and the 0 and the 1 and the 2 into this equation, you're going to have to do that here to find the average rate of change. I'm going to give you a hint. These ones are, I'm going to give you a picture of what we're doing on 14 and 15. One of these, the rate of change is going to be the same. But the other, because this is what's happening, our rate of change will be different between the intervals. One's going to be the same, one's going to be different. And you're not going to be able to do that until you mathematically figure it out. If you need more help with 14 and 15, I want you to ask questions to the substitute or to the person sitting next to you, because I believe that they will know how to do it. Everything else that's on here, I think you're going to be able to do. You're going to be able to take a table and plug in values and figure out what goes in the boxes. And we'll talk more about this. This is actually how you can figure out how much an investment will grow if it's gaining an average rate of return. And that's where I'm going to end your notes. I hope that you understand what it is that you're supposed to do. You should be able to do the 5.3 notes. And if you have any questions, just ask the sub. Thanks.